Yeah, I did a couple small modifications right now on the radius tool. I added a dowel hole here, a dowel hole here, and so what you can do is if you come down and hit this edge over here, that lines this side up real good. If I set it up here, it lines it that way. And so what I'm doing now, before I put everything back together, I'm going to establish the center line of my spindle with the center line of here, and so I just simply do that with an edge finder and with a dowel. It'll be plenty close for everything I need there. I got my zero established, and what I can do is I can pull this out now, and then what I can do is I can put the unit back together again. So basically this is all I got. You can see I got a pin with a head. Right now it's soft, again as a prototype. I'm just playing with it and testing it. Once I get everything ironed out and all the different stuff I want to put on it, I'll make a nice hardened version. Many people made comments in the comment section about the different uses and purpose. Talk about using it on sanders and everything else. One of the places I do mention in another video here is using it on the surface grinder. To take some of the old inserts and swing bigger radiuses with a diamond wheel, holding that up at whatever angle. I think these are 11 degree, and then that way I can get a real nice precision radius. I can control the size of the radius, the smoothness of the radius, and so I can grind the radius on there, and then I can grind flat on the top. I won't have the chip breaker geometry on here, but I can still repurpose these used inserts and get a lot more life out of them and special purposes. So that'd be another nice advantage that I have with that. But anyways, just make sure all the surfaces are clean. And right now this is just a washer that I'm using in the back. It'll be all different. Again, I was just using some of the stuff I already had built instead of rebuilding everything. Let's see, we'll tighten that up. And what it is, this pin is about 1/1000th longer than both of these parts put together, so I can tighten her down pretty good and not worry about this back piece loosening up on me. And it provides a nice pivot point with no play in it. And I may have just a little bit of some particles in there, but and again, this is all rough machine, and so in the final ground version, everything will have a much better fit. What I got going on right now, this is a piece of 3/4 A2 drill rod. What I have going on now is I had one of my palm to the forehead moments over on the adjusting mechanism on my squareness gauge. I was focused on the ball on the one end, and I wasn't even thinking that I needed a pivot point on the other end. I would have found that out soon enough, but one of the subscribers, Barry, pointed that out, and as soon as he said it, like I say, it was the palm to the forehead moment. And so the whole design is going to change on that, but this is what this video is about. When I build stuff, a lot of times I go through stages like this, and sometimes I can pull some bozos, some things that just escape my mind. What's kind of neat and unique with this, by sharing it on YouTube, there may be some stuff that I'll miss that I'll probably pick up or might not pick up, but with all the viewers and subscribers watching this, they'll point things out, and there's been a lot of excellent comments and suggestions. One of the things I want to mention as well in there, almost every time I do something on the mill that you can do on the lathe, people ask me why I'm not using the lathe. Well, that little Rockwell lathe we have, we really appreciate a good friend, Gary Walters, who letting us borrow it. And so it's not mine, and the lathe is in rough shape. I won't even go into all the details on that. I mean, from the chuck to just about everything it is. And I do use it, so I'm very appreciative that he let me borrow it, but I use it on a very limited basis on certain things. And so anyhow, I default to the mill a lot for a couple reasons. One, it's newer. The chuck on the lathe is worn. It's hard to get stuff running through, and if it's a nominal diameter that fits an R8 shank, I just pop it up there and it's running real true. I have no digital readout on the lathe, and so forgetting my sizes with my steps and everything is much harder. I have the DRO here on the mill that I can take advantage of. And as far as fixing up the lathe, it's too far gone, in my opinion, to really fix up. I will fix up some real simple things, but I don't want to put a lot of time or money into it. We do have Clausen Colchester multi-turn lathe that we have our eyes on. We want to buy that brand new sometime in the future, and it definitely won't be a near future. The last time we checked the price, it was about $65,000. So we'll definitely have to have enough things that I can use on that to justify getting that. I know that once we purchase something like that, just for setting up for hard turning, which we know very well. I know that in this area I can generate a lot of work for it in just that area. But I'm trying to stay away from the job shop mentality for now, and getting outside jobs from other companies. It's kind of a dog-eat-dog world, and the prices, the amount that you can make, you're always competing against people that are lowballing. You get to the point where it makes it really hard to make money. If you got manual equipment, you're competing with CNC equipment. There's very, very few things that you can do on a manual machine where you're going to be able to compete against the CNC. So anyhow, if we can make a quality product, and that's kind of our drive, is making a quality product, something that's kind of unique, something that's one of a kind, and selling these items. That's kind of where we're wanting to go right now, because then we have control of everything. And right now, when we're doing it on manual equipment, it may cost a little more. We're hoping someday to get into CNC equipment. But anyhow, I have to change that mechanism for the jest unit over there. Oh, before I go there, one other reason that I'll do things on the mill over here, and I mentioned that too. I know there's a lot of viewers out there that they have a mill, but they don't have a lathe. You know, they may have other tools. They might not have everything that they need. And I've come across a lot of people say, well, I wish I had a lathe, I could do this. Well, I'm just wanting to show you, if you got a mill, there's a lot of things you can do on a mill that you can do on a lathe also. And if you just make some little tools like this, some of this stuff is very fast, very accurate, and very easy to do. And you may find yourself preferring to do some of this stuff on the mill rather than lathe, even if you had it. I had a number of people already comment about that for simple things like that, the mills are go-to. So anyhow, that's some of the reasons why I do the different things right here. So anyways, what we're going to do is, the design is different. I got a piece of 3/4 inch drill rod. I edge found on the center of this pivot pin, and earlier I had this in there, and while I had it in there, I edge found on this surface, and I wrote down on my tool what it is from that surface up to get me to the center line of my tool. So now I got my locations for both things. Right now I'm winding it over. and I'm gonna lock the table down when I get to 0 here. And so now I'm locked down in the y-axis at 0, and so that tool should be on 0 with the spindle within a thou. And I did edge find. If I move over here, I edge found, and I'm at when I'm come to 0 on my digital, the center line of the spindle, center line on that as well. Well, one of the things I need to do right now, the part I'm going to be making right now, I'm going to use a ball in the top part of the mechanism, and I will use a cylinder in the bottom part to achieve 2 types of pivots. And so I need, on the top part, I'm going to cut this at 5/8 diameter. Actually, I'll have to check that. I'm going to make it 3/4 inch diameter first, because I think, now that I'm thinking of it, I didn't bring my CAD system out here to the shop. I'll have to do that to just check the numbers. But it doesn't really matter, because I'm just going to test the concept cheap and dirty out here right now, just to see if I can get things working the way I want. So I'm just going to run a 3/4 inch spherical ball on there. This drill rod's about 750, and it's usually plus or minus, well, usually about +1 or so, 5/10 to 1. So what I can do is, if I'm just doing a spherical radius on that, if I set my spindle on 0, 0, and then I give me a wrench, loosen this up. Yeah, I already got it loose. I got one still tight here, it looks like. There we go. What I can do, just for a quick reference, I can just bring this down. And because this is carbide, you got to be very careful. You don't want to smash. I'll probably sand this down a little bit more, make that a little bit easier to adjust. But basically, let me just tap it a little bit, get it closer. There you go. And I can just push that right up against there and hold it. And that's gonna give me a rough feel for where I need to be. And if I wanted it more accurate, I could actually put another piece in there and just slightly come up, take a light cut. I can dial her right in if I wanted to. But for what I'm using here, it's going to be plenty close enough. Now here's the case, if I wanted to turn the diameter down some, you know, I could in the future make this so I can lock this in place as well. I can use this as a lathe tool and just come down and touch, and you can see I'm in a little bit. I need to really back off, maybe about a half hour or thou. But the radius I'm turning it just for test purposes. The diameter is not real important. I'll be plenty close enough. So anyways, what I'll do at this point is I'll push that dowel back in. There we go, just get it out of the way. And I'm going to adjust this back just a little bit and get her spinning just a little bit easier. There we go. And come over here, get real close to the bottom, and lock my quill down. Just lined out. got less than 2 thousandths to go right now. And I'm just going to try to spin this nice and smooth. And I don't have to come up like I have been doing on these other pins over here, because I'm just going to be using the bottom half of this radius for what I'm doing here. So we have the radius on that. What I'll be doing maybe a little bit later on in this video, we'll probably be taking and showing some different type of radiuses that you can do, moving offset. I don't know if I'll do it in this video or another, but you can do your concave, convex. You can put your radiuses on bigger parts. You know, if you want to break a nice radius on corners, top or bottom, in the middle. Your tool, somewhere down the line I'll be making a couple things. One, as one viewer mentioned, and I did have in mind, is making a handle on here so I got a little better control and my hands are away from the chips a little bit. These chips right here, they weren't hot enough that they were even bothering. They were kind of warm. But the thing is, when you get a bird's nest up there, and then it can get a little bit dangerous. And so I was watching pretty close for all that. But by having a handle sticking out here, you'll be able to have a better control and a better feel of things there too. And so anyways, we'll be showing some other types of cuts that you can do with this tool. And I'm hoping I can get it in this video yet. So we're going to continue. We'll be moving this out of here. Once I drill a clearance hole on the bottom of this, I'll be cutting this off, and then what I'll be doing is I'll be grinding that top surface of that ball so it's a nice finish. And we're going to be using the contact area of this ball right there for the top part of the adjusting tool, where the little knurled knob goes. I was just looking on my steel rack, and I found this piece of co-roll over there. This is a failed project that I had in the past. Basically what it was, the design that I was going to use to hold this face mill that would go inside there. And I'd have the 2 dowel hole locations that would work for that. And anyhow, I wanted to build this all one piece for rigidity, but I was thinking what would happen if I would build this so it locates at the top part off this diameter. What would happen if I'd make that so that it could locate off this big diameter here? I was looking for rigidity on there. And so I actually got this made so that it will fit up in, let's get this up. And then it seats right up in there and on the bottom of that, so it picks up off of there. That didn't work very well, so I got a piece of co-roll though that fits right in there. I can play with a bigger diameter. What I did, I made this unit instead, and I really got the rigidity off this increase quite a bit. What I'll do is this uses with a 3/4 inch collet. And what happens is I'm using the bottom of that spindle so that this sucks up on the top and keeps it from wanting to pivot and spin. If you buy, if I remember right, this has a 1/2 inch pilot hole, and if you buy R8 shank on it, them things are so flimsy I don't even know why they sell them. But going with this and with the 3/4 inch collet, I was getting over twice the depth of the cut as I could using the bought R8 shank. And this cutter actually is one of my favorite cutters right now too. So it cuts really nice, and you got 3 cutting edges, and these inserts, they got a nice coating on them, and they just last and last and last. But anyhow, I have the dowel pin set up over here so I won't go past 0. And what I'm going to do, I want to establish the size right now because I'm going to change things. So I'm going to lock that one down. Come back on 0. I had to remove some material for getting a bigger diameter. I had to remove some material. And other ways you can do it is just build another pivot block, but make it thicker, you know, in this direction where the tool comes out more, and then you can put bigger parts in there. Using the quill feet on here right now to give a nice, consistent, even cut. That's one of the nice things having a digital readout on here. I got 2 inches, 399 and 9/10, 1/10 off the 2.4 I was shooting for. We got a nice finish on it. So I know I'm 2.4, and that means from the center line of my spindle up to the edge I'm 1.2. And so I can do simple math to do any adjusting here. I'll figure that out, what I need to wind over based where my digital's set right now. Actually, this would be a good place to use your absolute and incremental settings. And let me see if I can do that real quick without messing things up. Yeah, there we go. Yeah, we'll save a step of math right there. So I can have the absolute based on the center here, and then I can go to the incremental and set that 0 off that edge. So I'll do some math and we'll be right back. And so basically what I did, I took a cut. This come out to 2.4 inches. So from the center line it's 1.4. When I made that cut, our digital was sitting at 825, and the difference between the 1.2 and the 825 over there is 375, and that's what we had the radius set for. So if I want to say put a 1/8 inch radius on here, what I can do is that 825, I know I got a 375 radius sitting now, I can just move over 250 thousandths. So let's see, 575, or actually it's the other way. 1 inch 75. So if I set my digit to 1 inch 75, okay, I use my scale, which is about 20 thousandths to set the bottom. I got my digital set 20 thousandths from 0. That's where I have to come up to. Go ahead and get it within about 5 right now. The coat roll doesn't break up as nice as that tool steel. Yeah, I actually went past it. I did the math. Should have done the math first, but I should have stopped at 1.75, and then I would have had the nice radius on there. Obviously, again, I have no way to stop real perfect right at the point or not. At the halfway point in a future version we will. So anyhow, that's how you would swing a radius, and like I said, I messed up a little bit because I thought I'd go a little bit deeper than what I needed. So I'd have to bring up the last 5 thousandths. And just swing it up and I'll eyeball it in there. Anyhow, you can put some nice precision radiuses on your parts simply by doing the math, and you can get that. And actually that's leaving a really nice finish. I don't know if Kat can get up there and do kind of a still picture. And like I said, I went a little deeper, but again, this is for demonstration purposes anyway, so I'm not making anything, I'm just playing with it right now. What we're going to do is the convex radius right now, and I knew from the previous relationship I had when I was at 825 on my digital, based on the diameter I cut, that was set for a 375 radius. And so what I want to do now, actually a concave radius, that means I need to move over 375 to get that right at 0 from my 825, plus another 250 in order to get the 1/4 inch convex radius that I'm shooting for.
Concave.
Or concave. And so I got everything set for it now. It's in the proper position. And actually I got to take a couple burrs off that part that I milled. When I get that done, I'm going to smooth that out a little bit too. When I get that done, we'll be right back. And make it easier to adjust. And I just used a little sandpaper to get this so that it be easier to adjust. And I got our numbers set on the digital, and if my math is correct, we should I'll be setting at a 1/4 inch concave radius. And because of the geometry of the insert, I might not be able to get a nice convex on one side when you do the concave radiuses. A lot of times your cutter geometry gets in the way. You don't have as much problem when you're doing the convex. I'm just starting to hit with the back side of my insert now. And we're going to call that good right there, because I'm limited with the insert itself. Yeah, we'll let Kathy get down here with the camera and do some shots. Let's see if we can get a light background on here. My radius is off. I had to recut on this to get that 1/4 inch radius. My math was correct, but the base number that I had in my head was 25 thousandths off. And luckily I wrote that number down as far as where my pivot point was on there. And I always tell people, always double check your numbers, and I need to follow my own advice here. But anyhow, you can see with the still pictures how nice of a job the radius does. And when I'm setting it this way, it's just kind of a rough check or a rough setting. We can come up with something that can make that even a lot more precision. But when you're roughing stuff like this, a lot of times that's all the more you need. So anyhow, what we did, we had a limitation on the back side of the insert. You can see at the bottom in the still picture where I would hit that side. So to get a full convex radius or concave radius, you would need to probably go with a round insert style, but I'm limited in the tools that I have. So I'm going to try something else. We'll see if it works. I'm going to go ahead and wind this off a little bit. I'm going to go ahead and wind it up. Well, actually, I don't even have to wind it up because I'm playing with it. I'll do this the easier way. So what I'm going to do, just for safety reasons here, we have the cube on the back side. Again, this you'd use a different style insert, and I'm setting up this clamp so that I can't go further than that down because I don't want this to catch on that side of that insert. But we'll see what we got to go here now. So if you had the right tool, you can actually put that radius in a lot deeper in any place on that diameter you want. So now you're able to even do it on the face of the part. And so you're able to put I don't know if Kathy can you zoom up and catch that there?
As close as I can get it.
Okay. And then we got the radius on there. And Kathy will probably set this on the granite table and do some close-up steel pictures so you get a better look. But there's a lot of neat things that you can do with a tool like this. And you know, this is just exploring a few of them. And again, a lot of it depends on what style tool that you use to set up on this system. If you get some grooving style inserts that are full radiuses at the front, they'll work better for doing all the concave shapes. And so in this case, with the convex or concave, I kept hitting this back side over here and was very limited what I could do. We made a change in our pivot action over here. One of our subscribers, Barry, he pointed out that I need to have a pivot at this end too, and that's as soon as I read his comment, that was one of your palm of the hand to the forehead duh moments that I had. I got so focused on what I wanted to do on the bottom, I wasn't even thinking of the top. And this is stuff that's really basic and elementary. My toolmaker's vise, I got the same mechanism I now have over here, and so So that was a bozo moment on my part, and a big thanks for Barry for pointing that out and picking it up right away. And that's the kind of the nice beauty of doing some of the YouTubes as I'm building over there. You guys will catch some stuff that's just not on my mind at the time, and it works out great. So anyways, what we have now is I'll pull it apart later, but we got a spherical radius over there, and it's riding on a internal chamfer like here. So you have the tangency point of the spherical on the tangent point of the angle over there, and that's what it pivots on all the way around. And we went with, as many of the viewers, subscribers mentioned, with the cylinder down on the end. Now the cylinder, I'm going to go with that, but I'm going to make the contact point a 2-point contact rather than a round hole. So I'm still going to play around with some ideas there. But what I'm looking for in here is I want something that has a lot of adjustment. I want something that adjusts nice and smooth, something that I can adjust and stop at certain spots. And so I think this is working pretty good so far, at least in the testing. So you can see it's a nice smooth adjustment. Oh, one other thing I do, I put another die spring in here. I got one over here and one here, so I got quite a bit of spring pressure. And what was happening, I can feel that this is an unground surface on the other end there. It was just machined, and it was rubbing a little more than what I wanted. So I had this little needle bearing set over here, which is a little bit bigger. I'll get some smaller ones, but I popped the needle bearings in between there and actually improved the smoothness and everything else. And these things are quite cheap. You can get them on Amazon for under 10 bucks a set. But actually I think they're about 4 or 5. But you can see how smooth that's working. And I can pretty much stop it where I want. And the other thing, when I thunk on this part that's being adjusted, everything's nice and tight. You can see it's really not moving off to zero. A lot of the times when you have to reach down and twist the dial on the indicator, you can see all the movement I'm getting, and so you can fool around a little bit until you get zero. This is why I wanted to get the adjustment like that, so I don't have to frog around with it very much. But the other thing that's important is that you can get a repeatability as you come off and on. And you can see I'm staying between, well, right about 50 millionths above zero, kind of where it was stopped over there every time. And again, that's with pads on there that are machined. They're not even ground. When we grind everything up, and all this other stuff is machined, nothing's ground. Nothing's hard, and when it's actually in its final finish, everything will be smoother and nicer. But we're going to have Kathy change her camera angle, so I'll just show you some of the components here. One of the other nice features about this is if you want this to be nice and solid, you can just tighten that right down, and now it's solid. There's no movement, so that's going to be another nice feature, and that will make the squareness checker pretty much like the original one I built and the way I've been using it, and then it's rock solid. The adjustment here, as I move it, I want you to see what happens. What happens is you got this threaded rod that pivots as this angle and this part rides up. It will have to pivot according to that, and so with that ball down here, it needs to pivot as that rises. And so what you'll notice is that as this angle on this part changes, this will change. So watch right here and watch right here, and you'll see that we have a perpendicularity that's always maintained on this surface with the screw, but we won't have that perpendicularity from the screw here. And that's why we needed a pivot point at this other spot. And then you can see the amount of travel. Let me just get this set to the end. Can you see that much of it, Kathy? Mm-hmm. Okay, so this will give you an idea of the travel we have on there. Is it all refocused and everything?
Give me 1 sec.
Yeah, and again, you're watching the relationship of this surface and this surface changing as the adjustment goes.
All right.
So if you look over here, you can see we still have a perpendicularity with the screw over there. We lost the perpendicularity, which we wanted to, with the screw from there, because as that pivots, it's going to go at an angle. And if you look over here, you can see we got quite a bit of travel out of that fine adjustment. So I think this will probably be the method I will go with a few modifications yet. But let me pull this all the way off and there we go. And you can see the good sized die spring. I'll probably play around with the different stiffnesses of that and get it tweaked in. But this is the ball that I made. Got me a little couple fixture devices that I can use to make that thing out actually quite fast. What I'll do in the future when I make these, I will send them up for heat treat, and then I'll use a CBN or ceramic, more than likely ceramic with no interrupted cut, and then I'll get me a super good finish on there. So the smoother the finish, the nicer it will adjust. And so we got the pin right here. I'm going to pull this spring out. But that will pivot with this barrel down there, and that piece of drill rod with just a 1/4 tap thread through that. So anyways, that's just kind of a quick update on where we're at with that. I'm pretty happy with how this is working so far. So it's not really in stone yet, but something very similar to this is more than likely the direction we'll be going. I will be changing how it pivots. We'll have the barrel pin yet, but instead of having a round hole in there, I'll have that riding on some angles as well that will be milled into the bottom of the plate. And so that way I don't have to worry about wear as it goes. It's always going to be 2-point contact on there. And I'll have something similar with that front end as well. And we'll see how that all works. But anyways, that'll be it for now. Thanks for watching.